We want to look at this problem, 1635, in Dr. Dujic's Physics 3 class. Two loudspeakers, A and B, are driven by the same amplitude, rather amplifier, and emit sinusoidal waves in phase. Speaker B is 12 meters from the right speaker A. The frequency of the waves emitted by each speaker is given, the same. You are standing between the speakers along the line connecting them, and are at a point of constructive interference. How far must you walk towards speaker B to move to a point of destructive interference? You might recall that for constructive interference the path length difference, delta 10, it's called the path difference, is an integer multiple of the wavelength, for constructive. For destructive delta 10 is a multiple, rather odd multiple, of half wavelengths. This right here. So, what does this picture look like? Distance here is 12. And we begin at some distance. That's a 1. B1. And we move closer to B, so that the distance to B, that is, the second distance to speaker B, is that. And that. So, what is this? Delta 10. For the, we are told that, at first you are at a position of constructive interference. So this is my B1 minus A1. And you move to a point of destructive interference. Or I might have it backwards. Let's just take the difference between delta x1 and delta x2. So delta x1, x2 rather, minus delta x1, that's my delta B, B2 minus B1, minus delta A, A2 minus A1, and that's just half a wavelength. The distance I move toward speaker B is a negative distance. I move towards speaker A, so negative delta A is delta B, so this becomes 2 delta B is lambda over 2. Or, the delta B I'm looking for is lambda over 4. Wavelength, of course, is the velocity divided by the frequency. And the velocity is that of air. So it's 344 of sound in air, divided by 4 times the frequency, 688, and what is that? 344 divided by 688 times 4. 344 divided by 688, I think, times 4 equals 125 meters should be the answer. There.